Good day, good morning, good afternoon, everyone. Welcome back to the GVU. This is the next in our series of In Conversation With. We've had some great conversations so far. As usual, I am Curtis Edwards. Joined with me is Ben Mayer, and we have a special guest in the studio with us today, Matt McSpirit. So in our In Conversation With, we've spoken to some of the members of product management. We've spoken to some directors. Now we speak to some of the feet on the street, the engineering technologists, the brains of the operation. Not to say that the other guys aren't smart by any means, but sometimes we like to take conversations in a more technical perspective. So with that, let's get it kicked off a little bit here. Matt, welcome. Thanks for joining us. Can you give us a little bit about your background? Tell us who you are. What do you do?
Yeah, thanks for having me. Thanks for including me. I'm Matt McSpirit. I'm one of our Geo's team members. I'm based on the west coast of the US, as the accent will give that away. I'm coming up to nearly 2 years at Dell, which has just flown by. It's crazy. And before that, I was nearly 16 years at Microsoft, focused on our Azure hybrid story. And I've continued that work at Dell, and just excited to keep the drumbeat going and helping people understand more about our upcoming Apex Cloud platform for Azure.
Awesome. Well, ironic, you said you were at Microsoft for 16 years, and just earlier this week we announced or fully made available for purchase the Azure Cloud platform, the Apex Cloud platform from Microsoft Azure. So what does that really mean to you? Like, what do you like about that? That we announced it at Dell Tech World.
Yep,
and now it's actually available for customers to consume and utilize.
That's right. Yeah, and what it means to me is it's a reflection of an absolute huge amount of work across the two companies, Microsoft and Dell, to bring to market the most co-engineered, collaboratively developed and built solution to run Azure Stack HCI OS that the market has seen, and really enable organizations who are looking to embrace Azure capabilities, services, processes on-prem in as quick a time to value and time to market way as possible. And it brings a whole host of innovation around management, security, lifecycle experiences, and just red hot brand new hardware innovation that just delivers so much for organizations. And we're just excited to get this in the hands of folks and organizations to continue with their on-prem Azure experiences that we've seen very popular so far with our in-market AX node-based platform. So we're just really excited. It's the culmination of a lot of work.
So you mentioned that it runs Azure Stack HCI.
Correct. Yeah.
But some of our customers already have Azure Stack HCI clusters, but yet this has a new name on it. Is it same? Is it different? Like, can you tell us a little bit?
Yeah, it's a common misconception. So the Azure Stack HCI OS from Microsoft, as many will know, is a subscription-based operating system that you run on a choice of your hardware. And today in market from Dell, the name of our hardware that we give to run Azure Stack HCI up until this point recently has been our Dell integrated system for Azure Stack HCI. So our hardware platform, it's if you look at the nodes, AX nodes is the terminology given to the actual nodes. They're based on the 15th generation PowerEdge platform, customized, optimized. That's an AX node within the Dell integrated system for Azure Stack HCI portfolio, and they run Azure Stack HCI OS. Fast forward to now, and our new 16th generation base platform takes that starting point of those amazing PowerEdge 16th gen servers with their improvements in security, sustainability, power efficiency, and a whole host more, optimizes them with specific componentry, and they form the basis of our Apex Cloud platform variants in the form of our MC nodes. And in the case of ACP for Azure, those run the same Azure Stack HCI OS. In fact, if you had an AX node side by side with an MC node both running Azure Stack HCI OS, it's the same Azure Stack HCI OS across both. And as we go forward, we're continuing to innovate around our ACP for Azure platform to just get more deeper integration between hardware, software, and cloud to really deliver the best hybrid experience for customers.
So is it safe to say that this Apex Cloud platform for Azure, or I'll just say ACP for Azure, is the next iteration in what we had previously. So the previous generation, like you said, with the AX nodes on 15 gen, and now this is the next evolution of that into the 16 gen platform with the name change, right? So
yeah, the name change is one big element. It reflects that broader Apex multi-cloud strategy that Dell has, including directional shifts for Red Hat and VMware in the future and more. When it comes to that jump from AX nodes established a really solid top-level foundation for running Azure Stack HCI on premises in terms of lifecycle management, integration with Azure services like Azure Policy, intelligent capabilities that made the admin's life much better. But then VMware admins have had that kind of capability and more for a long time with VxRail, unique to Dell and VMware as that co-engineered solution. We've taken a lot of those learnings and that capability and that code from the VxRail side, and we've brought it over to enhance what the foundation was laid on the AX nodes, and just taking it even further with improvements in lifecycle management, security capabilities, a whole host of deeper integration points between hardware and software. So it's the starting point of AX nodes, and that integration was great and really a market leader in its time in the Azure Stack HCI space. We're taking all of that and taking things even further, including some unique innovation around new storage options for ACP for Azure, which haven't existed and won't exist for the current in-market AX nodes as well. So we can happily talk about that some more as well.
Right. So you just mentioned that obviously we have customers who are currently AX customers. What would be like an approach for them to make use of those new functionalities? Would it be like a site-to-site deployment initially, or how can they transition to the new capabilities?
Yeah, so what we see with most organizations who are now looking at ACP for Azure-based infrastructure is to complement and sit side by side with their existing AX node-based deployments, because most of those are still well within life cycle. So organizations have still got plenty of years left with those AX nodes. And as I said, the AX nodes run the same Azure Stack HCI OS as ACP. So they've got a consistency there from the virtualization, hyperconverged layer. But Dell don't support mixing mixed generation clusters in the same Azure Stack HCI cluster. So for example, you wouldn't be able to combine 3 nodes of AX with 3 nodes of ACP into a single cluster. Now, there are pros and cons for that decision, but Dell's made the decision to not allow that mixing to ensure the highest levels of reliability and supportability. But what we see in most organizations' deployments is Azure Stack HCI very much suited to the edge and remote sites and smaller deployments, certainly so far in its life cycle. So when you're getting up to the 5, the 6, maybe 7 or 8 nodes, it's a nice point to then introduce a second or third or fourth cluster, which introduces some management considerations. Each cluster from a granular perspective needs to be managed at quite a granular level using the tooling we provide, integrating with Microsoft tools. But as you start to grow your footprint with the number of clusters, let's say, for example, you are a retailer with 500 stores with a 1 or a 2 node cluster in each store, managing each of those clusters on a one-to-one basis, very time consuming, very effort intensive. And that's where fleet management becomes incredibly important. And Microsoft is driving forward to deliver a very intelligent, comprehensive, scaled fleet management experience from Azure to not only incorporate management of the Azure Stack HCI OS and its workloads, but more and more integrating with partner solutions from the likes of Dell, where we can integrate more of our hardware-based intelligence and management at that fleet level from Azure. So the goal long-term is definitely to allow organizations to manage that fleet more comprehensively from the silicon up to the workloads from Azure. And we just plug in at the right points with our intelligence and control and capability. And
you mentioned earlier that we will introduce as well later on different storage options. So as I understand, we have the offering based on Storage Spaces Direct, but there will be another storage option in addition to supplement that going forward.
That's right. That's right. So today with Azure Stack HCI, as it stands across all OEMs, this isn't unique to Dell. The only storage option for your hyperconverged workloads is the inbox storage, which is great. Storage Spaces Direct is a solution that transforms a mix of storage types, hard drives, SSDs, NVMEs, into high performance, reliable, redundant software-defined storage. And for the vast majority of workloads, it delivers an incredible level of performance and will continue, I would say, certainly in smaller edge deployments, to be the standard way that organizations deploy with Azure Stack HCI from a storage perspective. But that said, there are scenarios and situations where a hyper-converged architecture, single tier, doesn't fit. Where, for example, perhaps you have a small need for compute and yet a larger need for storage, capacity, specialized features and capabilities, whatever that may be. But the only way you can satisfy that in a hyper-converged manner is to keep adding more compute nodes, which, if your compute needs are low, that's unnecessary. Azure Stack HCI's architecture hasn't allowed any variance of that until now. So in the not too distant future, early next calendar year, from the Dell standpoint, we will bring to market the ability for our ACP for Azure offering to be complemented with what we'll call, for this example, sidecar storage. So it's something that sits by the side. It's running on those same MC nodes, and it presents block storage through to your Azure Stack HCI compute nodes. So imagine the scenario that your compute nodes now are very lightly populated. You've intentionally chosen to not fill them with lots of disks and capacity, just minimal amount of storage, enough for Storage Spaces Direct to function and be enabled. And then from there, your primary storage could be this additional block storage that's presenting. And this block storage has come from our heritage in building amazing solutions like PowerFlex. So this variant of PowerFlex that's running on these MC nodes, that's more customized and specialized for use with this configuration, enables you to have a two-tier architecture that can scale independent of one another. And it's not an either or. It's not a you have to use exclusively external storage or S2D. You could use a mix. Some volumes could come from S2D, some volumes could come from the external storage, and you place workloads appropriately and benefit from the flexible options that both of those complementary platforms provide. And this is a first for Azure Stack HCI, and Dell's the only vendor providing this solution. So we're really excited about this architectural revolution for Azure Stack HCI that's coming in the not too distant future.
That's pretty awesome. And when you say like a sidecar storage, so S2D is not going away, like you said.
Correct.
It's still going to be there. So will you consider the Dell software-defined storage to be secondary storage, and the S2D is still primary storage? So like, will all the virtual machines or all the machines have to boot from S2D, but then can get additional volumes elsewhere, or can that be intermixed?
Completely intermixed. And what I was alluding to in the previous statement was that it just depends on your workload. So for example, with the Dell software-defined storage presenting block, what you essentially see if you were looking from an administrator perspective at your list of volumes on your Azure Stack HCI cluster is you're just going to see what we term cluster shared volumes, which are volumes that are shared across all cluster nodes. That's the format that Azure Stack HCI utilizes. And you would place workloads in the respective volumes. And from what's backing those volumes perspective, it could be the external software-defined storage. It could be the Storage Spaces Direct. Both are capable of having VMs booting from them. Both are capable of running those different types of workloads. And as I said, we could see some organizations start with S2D in their compute nodes, and as they grow to a capacity point, then they introduce the external storage without needing to add more compute nodes. Or if they want to start very small on that inbox storage capacity, then they could add the external storage more upfront. But it's how they slice and dice is completely up to the customer and organization. What I would say is, though, is from a design and architecture perspective, Azure Stack HCI, as I mentioned earlier, has lent itself nicely to more remote office edge deployments because of its ability to start at a single node cluster, so just one node. And then for the smaller configs, 2, 3, 4 nodes, supports some nice switchless configurations, which help to keep the costs down in those restricted edge locations. When it comes to adding on the external software-defined storage, there is going to be a minimum capacity requirement in terms of number of nodes, and that may be too much for, you know, a sort of really small edge location with just 1 or 2 compute nodes, if you will. So I think we're going to see over time that shift, but initially the smaller scale configs will probably stick with S2D, and then the larger configs, manufacturing locations, core data centers, I think they'll more readily invest in that external software-defined storage to help grow those independent tiers, respectively.
I think that's go ahead, Ben.
I think that's really powerful, especially for certain workloads, for example, like data analytics or large databases. I think that's really a game changer for Azure Stack HCI. And I think as well, it opens new possibilities, right? Because we have new replication features that are part of PowerFlex that could be utilized. Replicate data to the cloud or to different locations. So I think there's a lot of possibilities there.
You're right. Yeah, that's a good point, because one of the other things we announced at Dell Tech World a couple of months back was our continued push into bringing our ground to cloud capabilities. And one way that that's being realized is the inclusion of our Apex block storage in the public clouds, AWS, Azure. And so with the example of an Azure hybrid config, you conceivably in the future could have Apex block storage on-prem or ACP for Azure storage nodes. And those could be in sync and replicating between an equivalent Apex block storage in Azure. And that could open up a whole host of different scenarios. And block is just the start, I think, for our storage push, both on-prem and in the public clouds, when it comes to attaching to these Apex Cloud platforms. So initially, ACP for Azure storage nodes will present block to the Azure Stack HCI hosts. But you can conceivably see that it continue to evolve to present file, to present new forms of storage, maybe integrating with Kubernetes, running on top of Azure Stack HCI. There's a whole host of options to plug into these different layers, and then corresponding what's happening in the public cloud as well. And it's one consistent storage platform helping to solve those multi-cloud challenges, which is where Dell's really pushing.
So you mentioned ground to cloud, right? And the approaches that we're doing there with block for AWS, block for Azure, and then the ACP family, which I'll call a family, which is ACP for Azure, ACP for Red Hat OpenShift, and ACP for VMware, is on the other side of that spectrum for the cloud to ground strategy. And you talked about being able to conceivably move data, whether it be on site or in the cloud, back and forth between the two common storage layers, right? For customers that aren't quite ready to embrace both ends of that spectrum, is there any intermediary? Can they do stretched clusters? I'm assuming they can. I'm not an Azure expert. I'm assuming they can do some stretched clusters between locations. They can do some replication. Can you talk a little bit about that?
Yeah, sure. Yes. It sounds like you're an expert. You've got all the right terms. So no, so with Azure Stack HCI generically, so regardless of AX nodes or ACP for Azure and the cool stuff we're doing there. So Azure Stack HCI generically, it supports what I'll call local clusters, where between 1 and 16 nodes, you can construct a highly available, resilient local cluster. And by local, I mean they're in the same rack, they're in the same room, that kind of stuff. And I know I use the term 1 to 16 nodes. How can you have a redundant cluster with a single node? Well, Azure Stack HCI does support a single node for, and all of the capabilities on there are fully functional and supported. It's just, if you pull the power out of that single node, your workloads will go down. There's nowhere for them to fail over to or live migrate to, for example. But single node clusters are a thing. They're great for cost-conscious organizations who've got distributed deployments and are willing to sacrifice some of the local redundancy for that flexibility of pricing and cost efficiencies. Anyway, so that's 1 node clusters. Let's assume you're looking at something more redundant, like a 2, 3, 4. With a local cluster, should a node fail, VMs will automatically fail over to another node in that cluster. And you can benefit when you've got the cluster of all the live migration capabilities as well. And all the replication that's happening between the nodes themselves in the software-defined storage is all across the backbone of those nodes. So high-speed links, 25, 40, even 100 gig links between those nodes, transmitting all of that change data between those nodes. Then we introduced the concept of geographically dispersed separation between some of these nodes. And so, for example, I use university campus as a good example of one where you might have capacity needs on, and you want to, from a DR perspective, place some compute on the east side of the campus and some on the west. But between those locations, it's essentially a LAN. It's fiber connected, the speed, the latency is non-existent. You've just got essentially a flat network across the two locations. So in that respect, you can build a stretch cluster consisting of, again, let's say 4 to 16 nodes as an example, because you wouldn't put one node on one site and one on the other to do two. I don't think that would be a great idea. So 2 and 2 on either side of the campus would be, I would say, the recommended minimum. So let's say you've got 4 nodes spread across that campus, east side and west side, west side and east side, actually. And essentially with in-box capabilities, you can determine, well, I'd like to establish this single cluster object. It's still just one cluster stretched across the two locations. I'll use in-box synchronous replication that I don't need any external tooling or special third-party applications or services. And it will replicate my space, my storage and traffic, my workloads, the whole lot across those two locations. It will still, things will only run in one active site or the other. You can have an active where VMs A, B, and C are on one site and D, E, and F are on the other. And in the event of an outage, they'll try and fail over locally in that site. So there is an awareness that these are two distinct sites, but they're still one distinct cluster. So workloads will fail over to the respective sites. In the event of we use our west and east side of the campus, let's use another example where Seattle or New York are your sites. Synchronous replication across that type of boundary is going to be pretty tricky because you can't always guarantee the links and the latency across that distance. So in which case, the stretch cluster can still be deployed. You can still have, let's say, 2 nodes and 2 nodes stretched, but in which case this time it will use asynchronous replication between the two locations. Again, it could be active, passive. A lot of flexibility, but now it's intelligent to know that synchronous isn't going to cut it. We'll use async replication between those sites. Everything else stays the same. Now, the devil is in the detail here. Your plumbing between those two sites, things need to still be able to find each other. The networking still needs to be accurate and correct to reflect this situation, but you don't need any third-party tools for this. But depending on your workload, that whole replication, the stretch clustering can have a performance impact. So we want to make sure that you're doing good validation and testing of your workload to determine that impact. If you wanted to go between mixed generation environments, so let's say you've got AX nodes in Seattle and you've got the new ACP for Azure nodes running in New York. Those are 2 distinct clusters. Remember, we said we couldn't mix the generations earlier on. The Azure Stack HCI layer is the same, but we don't mix our hardware cluster versions or generations. So in that respect, we're now in a situation where we've got 2 distinct clusters across those 2 sites. To replicate data between those, you've got to think about how you're replicating at the app level, and perhaps there are third-party solutions that you'd want to use to replicate VMs between those locations. But the inbox stretch cluster is not applicable in that scenario because it's not one cluster anymore. You've got that mixed generation hardware. So that would be an important consideration.
Gotcha. That makes sense. Yeah, I would like to shift gears a bit, and we have a lot of viewers who come maybe from a different ecosystem. They come maybe from a VxRail, VMware background. Could you talk maybe a bit about how the solution is managed, and maybe some of the hybrid aspects, like what we can do from the Azure console versus maybe the admin center?
Yep, good. Yeah, and we welcome everybody over. You know, whether you've got a VMware background, you're more than welcome to come and play in the Azure sandbox. So it's a good question because there is a delineation of where you manage locally with local tools, and I'll elaborate on that in a moment, and where you go to more of the higher level, fleet level management. And it may be different teams have those different responsibilities depending on how organizations are organized. But so local tooling, from an Azure Stack HCI cluster perspective, running whether it's AX nodes or ACP, the Microsoft tool that Microsoft provides is Windows Admin Center. And Windows Admin Center does a multitude of things for an environment, not just Azure Stack HCI. So if you wanted to manage file servers and Active Directory roles and certain other elements, it's very much a jack of all trades. However, it has an extension model where Microsoft partners plug in with extensions that tailor functionality specific to what you're trying to manage. So in the case of our current gen offerings, our AX nodes, we have our Open Manage integration with Windows Admin Center. The acronym is very long and tiring. But what that does is essentially it gives us a plugin for Windows Admin Center that when you go into that, you see more depth visibility about our AX nodes and the clusters, and perform things like hardware lifecycle management and IDRAC-based configurations, locking things down from an infrastructure security perspective, and more. But it's a very granular one-to-one relationship. I'm going to manage this cluster, then I'm going to go over to this cluster and this cluster, and that's not necessarily the most scalable. Now, going forward with ACP, we take the same extension plugin approach into Windows Admin Center, but it's a new extension that manages the granular nature of ACP nodes. So it's a slightly different extension. So if you were managing both AX node platform and ACP, from Windows Admin Center, you would see two extensions, and you would manage those respective clusters through those. And it gives you all the granularity, the depth level configuration. It means that you don't have to go off to the IDRACs individually and do things at that level. It centralizes a lot of that hardware level and integration with software. Now, that's all local. Once you start to deploy more than 1, 2, 5, 10 of these clusters, Microsoft is building more and more Azure level management into its overall experience for non-Azure based resources. And Azure Arc is a key enabler of that. But once your Azure Stack HCI clusters are all registered, they appear in the Azure portal. So I could see all of my retail stores running Azure Stack HCI. Regardless of AX or ACP, I could see all of my different Azure Stack HCI clusters. And then I can start to turn the dials on more fleet management, VM deployment across all those locations, Kubernetes cluster deployment going forward. Update management is something that's coming down the line, monitoring across all those different clusters. So we're really harnessing and using Azure as the linchpin for that fleet management experience across the board. And Dell is plugging in intelligently into those different experiences, such that in the future, we'll have a more joined up software hardware experience from Azure. Azure today doesn't really do anything with hardware specific capabilities outside of things that live outside of Azure today. And that's certainly where we're looking to push going forward and really innovate in that space.
Okay.
Well, Matt, it's been an absolute pleasure. Thank you so much for taking the time out of your day to join us today. You want to plug any of your social media at this, or I was about to say Twitter, X, whatever the new stuff is. You can plug it here, you blog, anything like that, right? How can people get in contact with you if they wanted to find you?
Yeah, so I'm on Twitter at Matt McSpirit, or whatever Twitter previously was. And you can get in touch with me, any questions. I would keep sticking with the Geo's Engineering Technologies blogs, and you'll find lots of information, useful stuff on there. We have a pretty active YouTube space as a broader group focused on ACP for Azure, so we can certainly share those links with folks as well. There's some brilliant video demos on there, so you can start to see some of the stuff that I've been alluding to today, the lifecycle management, all the other cool stuff. So I would definitely right now direct your attention there, because that's where you can start to see some of this stuff in action. And we can also provide links to our GitHub repositories where they can walk you through if you want to get hands-on with some of this sort of stuff as well. So we can provide all of that for you.
Awesome. Well, again, Matt, thanks for joining us. Ben, as usual, another successful video. Gentlemen, enjoy the rest of your day. To our audience, please like, subscribe, hit the bell icon so you're alerted when we have new videos pop up on the channel. And with that, I bid you guys adieu. Take care, everyone.
Thanks, folks.